Our planet harbors 1.335 billion cubic kilometers of water, creating a liquid universe that dwarfs all terrestrial realms combined. Here, beneath the glittering facade of waves, exists an empire of life, where each organism contributes to an elaborate symphony of existence. Yet 95% of this aquatic cosmos remains hidden in perpetual shadow. Beyond the reach of storms, below the domain of whales, past the last glimmer of solar influence, the ocean transforms into something else entirely, the deep sea. This is Earth's true wilderness, a dimension of stillness, isolation, and absolute darkness, where mysteries drift through an endless liquid night. The ocean's upper boundary welcomes the sun's embrace. The twilight zone below catches its final whispers, spanning from 200 meters to 1,000 meters deep. Yet with the ocean averaging nearly 4,000 meters in depth, and its deepest trenches plunging to 11,000 meters, this twilight realm represents merely a transitional threshold. The ocean's subsequent territories each claim progressively vaster domains. The midnight zone, scientifically termed the Bathypelagic, extends from 1 kilometer down to 4 kilometers deep. Below this, the abyssopelagic unveils itself, presenting an immense desert of sediment across the deep ocean floor. The abyssal plains, a kingdom of those who dwell in eternal mud. In select locations worldwide, the seafloor fractures deeper still through massive canyons carved by Earth's tectonic forces. These are the ocean trenches, the hadal-pelagic zones. Penetrating these successive depths presents escalating challenges, yet humanity persists in its quest for understanding, achieving partial success while confronting vast unknowns. Modern technology has become our eyes in the darkness. Since the 1980s, robotic explorers have ventured where humans cannot survive. Consider the ROV Jason, operated by Woods Hole Oceanographic Institution, a mechanical ambassador the size of a small vehicle, pressure rated to 6,500 meters. Tethered to its mothership by a lifeline of fiber optics and power, Jason illuminates the void and transmits visions from Earth's hidden frontier. As our mechanical proxy descends past 1,000 meters into the midnight zone, reality shifts into something unrecognizable. Creatures appear that defy conventional biology. Some so minute they challenge perception, others achieving proportions that seem impossible. This is absolute darkness, a place where photons have never existed. The environment is merciless. Vast distances separate organisms from the plankton foundations of marine food webs, restricting population densities. Life must persist in perpetual cold, where temperatures never exceed 4 degrees Celsius, while enduring hydrostatic forces ranging from 100 to 400 times surface pressure. Despite these extremes, organisms don't merely survive. They flourish through extraordinary adaptations that push biological architecture to its limits. Every species represents a solution to seemingly unsolvable problems, evading predators, securing nutrition, and finding partners across an infinite black expanse. Consider the comb jelly's translucent architecture, tissue that endures crushing forces that would obliterate conventional organisms. Their gelatinous forms, composed of 95% water, remain unaffected by pressure that would compress air-filled organs into nothing. Metabolic processes slow to near hibernation rates. In this realm, patience becomes a survival strategy. The Greenland shark epitomizes this principle, dwelling 2,200 meters deep in Arctic waters, growing larger than great whites at 7 meters, yet living for centuries. Radiocarbon dating of their eye lenses reveals individuals over 400 years old, creatures that were young when Shakespeare lived. These sharks exemplify deep-sea gigantism, the tendency for abyssal creatures to achieve sizes that dwarf their shallow-water relatives. The giant isopod grows 50 times larger than its terrestrial cousins. The colossal squid reaches 14 meters. The Japanese spider crab spreads its legs across 4 meters. Predation in the midnight zone defies logic. In this nutritional desert where prey is desperately scarce, carnivores shouldn't exist. Yet they don't just exist, they dominate through strategies that conserve every joule of energy. Ambush predators perfect the art of stillness. A comb jelly deploys tentacles armed not with stinging cells, but adhesive colloblasts, biological flypaper that ensnares victims. Delicate rows of cilia beat in synchrony, propelling the jelly while refracting phantom rainbows through the darkness. These same structures generate their own illumination through specialized photosites, bioluminescence that may lure unsuspecting prey. The female anglerfish has evolved nature's most patient fishing method. Her modified dorsal spine extends forward, tipped with an esca, a bulb containing billions of bioluminescent bacteria. This living lantern dangles before her cavernous mouth, drawing curious prey to their doom. But finding food is only half the challenge. Reproduction in this vast emptiness seems nearly impossible. Anglerfish solve this through extreme sexual dimorphism. Males, reduced to 1/10 of female size, possess enhanced olfactory organs to detect female pheromones across kilometers of void. Upon finding a mate, the male literally fuses with her body, their circulatory systems merging until he becomes nothing more than a parasitic sperm factory, fed by her blood. Body architecture in the midnight zone follows different rules. Surface predators like tuna exhibit fusiform bodies, streamlined torpedoes built for speed. Reef fish are laterally compressed for agility. Benthic species are dorsally ventrally flattened for bottom dwelling. But here in the midnight void, no seafloor exists for thousands of meters. No structures provide cover. 2 body plans dominate. The globular forms of anglerfish, built for hovering rather than pursuit, and the elongate serpentine forms of eels and dragonfish. The gulper eel embodies this second strategy. Its mouth comprises 25% of its body length, unhinging to engulf prey larger than itself. Its whip-like tail produces undulating waves that propel it efficiently through the darkness. The snipe eel takes elongation to extremes. stretching 2 meters long, yet remaining thinner than a human thumb, with over 750 vertebrae, more than any other animal on Earth. Color in the midnight zone tells a story of evolution in the absence of light. Here, the mirror-like silvery fish of the twilight zone give way to creatures of absolute darkness. Many species have evolved ultra-black skin, surfaces that absorb 99.5% of any light that touches them. This isn't ordinary black, it's a structural marvel. Melanosomes, cellular packages of melanin pigment, are arranged in dense layers that trap photons like a forest of microscopic trees. Light enters but cannot escape, scattered endlessly until absorbed completely. The Pacific blackfish demonstrates this adaptation perfectly. When illuminated by submersible lights, likely the first light to ever touch them, they don't reflect or shine. They remain voids, shadows darker than the surrounding darkness. Yet some fish reject camouflage entirely. The loose-jaw dragonfish produces red bioluminescence, a wavelength invisible to most deep-sea creatures. It has evolved private spectrum vision, seeing what others cannot. Its red searchlight illuminates prey that never know they're being watched. Biological night vision in a world already dark. The viperfish displays another strategy. Its fangs are constructed from transparent nanocrystals smaller than light wavelengths. These invisible teeth strike before prey detect danger. The crystalline structures are so precisely arranged that light passes through without scattering. Natural fiber optics evolved millions of years ago. Bioluminescence here serves different purposes than in the twilight zone above. There, it provides counter-illumination camouflage. In the midnight zone's absolute darkness, light becomes communication, hunting tool, and defense mechanism. Dragonfish sport rows of photophores along their undersides, not for camouflage, but for species recognition. Each species displays unique patterns, like facial recognition in living light. During mating seasons, these displays become elaborate courtship dances performed in biological LEDs. Every 10 meters of descent adds another atmosphere of pressure. At the midnight zone's upper boundary, pressure reaches 100 atmospheres. At its lower limit, 400 atmospheres. This is equivalent to balancing 400 kilograms on every square centimeter of body surface. Survival requires revolutionary biology. The chimera, a cartilaginous fish older than dinosaurs, has existed here for 400 million years. Along its body runs a lateral line system, a network of pressure-sensitive cells that detect the slightest water movements. In absolute darkness, it sees through pressure waves. For cephalopods, soft bodies become an advantage. The Dumbo octopus, Earth's deepest living octopus, reaches depths of 7,000 meters where pressure exceeds 700 atmospheres. It propels itself with ear-like fins, its gelatinous body immune to compression. Being mostly water, it exists in pressure equilibrium with its environment. The glass octopus takes transparency to extremes. Only its eyes, optic nerves, and digestive tract remain visible. Males carry a hectocotylus, a specialized tentacle for transferring sperm, while females can reach 45 centimeters. Their bodies dotted with chromatophores that can darken for camouflage when needed. But perhaps the most remarkable pressure adaptation belongs to deep-sea fish swim bladders. Surface fish use gas-filled bladders for buoyancy. At depth, gases compress to nothing. Deep-sea fish fill their swim bladders with oils and lipids, incompressible fluids that maintain constant volume regardless of pressure. Some species go further. The midnight zone is Earth's largest food desert. Photosynthesis is impossible. Plankton are absent. Nutrients arrive only as marine snow, a continuous drift of organic particles falling from above. A single particle might take weeks to descend from surface to sea floor. The vampire squid has mastered this meager resource. Neither true squid nor octopus, it represents an ancient lineage that diverged 300 million years ago. It deploys a unique tentacle covered in adhesive mucus, collecting marine snow like a living cobweb. This creature thrives where others suffocate. Its blood contains hemocyanin with the highest oxygen affinity known in cephalopods, allowing it to inhabit oxygen minimum zones where competition cannot follow. Yet occasionally, the desert receives a feast. When a large animal dies above, its carcass delivers more nutrition to one location than normally arrives in decades. Sixgill sharks detect these windfalls from 30 kilometers away through chemical gradients. These prehistoric predators, unchanged for 200 million years, can grow to 6 meters and live for 80 years. They arrive first at carcasses, their powerful jaws tearing through flesh with serrated teeth. Hagfish follow, primitive vertebrates that haven't evolved in 300 million years. They enter carcasses through any opening, consuming from inside out. A single whale carcass might attract 400 hagfish, transforming the body into a writhing mass of primitive scavengers. But most remarkable is the mother black-eyed squid's sacrifice. She carries 2,000 eggs in membranous sacs for 9 months at 2,000 meters depth. During this period, she never feeds. Her body deteriorates, muscles wasting away as nutrients transfer to her developing offspring. This single reproductive event kills her, but ensures the next generation's survival in this unforgiving realm. Gelatinous organisms rule the midnight zone. Free from the constraints of rigid bodies, they achieve sizes impossible for other animals. They account for 40% of the zone's biomass, a dominance only recently discovered. The giant phantom jelly, Stygiomedusa gigantea, embodies this supremacy. Its bell spans a meter across, while its forearms extend 10 meters, living curtains drifting through darkness. These arms lack stinging cells entirely, instead engulfing prey within their massive folds. This titan participates in unexpected partnerships. The pelagic brochula fish lives within its bell, feeding on parasites while receiving protection. The fish possesses specialized neuromasts that detect the jelly's pulsing rhythm, allowing it to return if separated, navigation by heartbeat in the darkness. Deep Staria jellies demonstrate another strategy. Lacking tentacles, they engulf prey entirely within their bells, which close like drawstring bags. Their digestive systems spread across the bell's interior in mesh patterns, distributing nutrients throughout their massive bodies. But the most alien existence belongs to siphonophores, not individual organisms, but colonies of specialized clones. The giant siphonophore Praia dubia reaches 50 meters. longer than blue whales. Along its length, thousands of zooids perform specific functions. Some digest, some swim, some reproduce. These colonies can fragment themselves, splitting into sections that might form new colonies. When threatened, they shed zooids like a lizard drops its tail, sacrificing parts to preserve the whole. This modular existence blurs the boundary between individual and collective, organism and ecosystem. The midnight zone isn't merely a habitat, it's Earth's climate engine. The biological pump operating here transfers 10 gigatons of carbon annually from atmosphere to deep ocean. Without it, atmospheric CO2 would double within decades. Every night, the zone participates in Earth's greatest migration. Billions of organisms rise toward the surface to feed, then descend at dawn, carrying surface nutrients to depth. This vertical conveyor belt connects the entire ocean system. The zone faces unprecedented threats. Deep-sea trawling destroys thousand-year-old ecosystems in minutes. Microplastics contaminate every level of the food web. Ocean warming disrupts the stable temperatures organisms require. Acidification weakens the shells and skeletons of countless species. Deep-sea mining threatens to industrialize Earth's last wilderness. Companies target the zone's polymetallic nodules, mineral deposits that take millions of years to form and support unique ecosystems. A single mining operation could destroy habitats the size of cities. Yet the midnight zone may hold keys to humanity's future. Bacteria here produce enzymes used in medical diagnostics. Compounds from deep-sea sponges fight cancer. The pressure-resistant proteins of zone inhabitants could revolutionize biotechnology. We've explored less than 1% of the midnight zone. Every expedition discovers new species. In 2022 alone, researchers identified over 30 new species from single surveys. How many more exist in the darkness? 4 kilometers below the surface, pressure exceeds 400 atmospheres. Temperature hovers at 2 degrees Celsius. No photon of sunlight has ever penetrated here, nor ever will. This is the midnight zone, Earth's largest habitat, its least known frontier, its most stable environment. Here, evolution has crafted solutions we're only beginning to comprehend. Fish see with transparent heads and invisible teeth. Squids communicate in languages of light. Jellies grow to impossible sizes. Colonies blur the distinction between one and many. Mothers sacrifice everything for offspring they'll never see survive. This darkness has persisted for hundreds of millions of years. Before flowers existed, before birds flew, before continents took their current positions. The creatures here are older than mountains, their lineages stretching back to life's early experiments in complexity. As you go about your day in the sun-drenched world above, remember that beneath you exists an entire universe in permanent midnight, a place where giants drift through liquid darkness, where pressure creates diamonds, where life makes its own light, where time moves differently. The midnight zone doesn't acknowledge our existence. It continues as it always has, processing carbon, cycling nutrients, maintaining Earth's chemistry, harboring secrets in its eternal night. We call it alien, extreme, hostile. But to its inhabitants, we are the aliens, creatures dependent on a narrow band of pressure and temperature, addicted to photons, trapped at the interface between air and water. Down there, in the permanent midnight, Earth's greatest wilderness keeps its secrets. And perhaps that's how it should be. Some mysteries are meant to be preserved in darkness.